Okay, let's keep practicing our knowing how to calculate protons, neutrons, and electrons, along with having the isotope of the different atom. So we have a couple things going on here. We have the element name over here on the left. We also have the mass number, or need the mass number in a couple of them. Remember, what the mass number is something that's not found on the periodic table, but it's actually a calculation of protons plus neutrons. So we can use that number to determine some of our columns along with the periodic table. So I just grabbed this and popped it in for reference, but you might have to go back and forth. And again, you have that paper copy from class, which is going to be the most helpful. So for starters, it's easiest to see what we can get from not only our table, but the periodic table as well. So the first one here is neon. Oh, let's also remind ourselves of charges. So I have protons, which are positive, neutrons, no charge, electrons, negative. So protons, I have 10 of those, which makes it neon. And I need to solve for neutrons, but I do have this mass number. So remember, this is protons plus neutrons. So I can do a quick subtraction. My total minus my protons allows me to know I have 17 neutrons. And in terms of calculating electrons, we know for electrons, I'm looking at the same as protons because all of these are in their neutral atomic state. So those will always be the same. Silicon here, I don't know the mass number. I also don't know the proton. So I am going to have to go to the periodic table for this one. So I'm searching for Si, silicon. And sometimes finding the atom is the hardest part. Here it is, silicon. So I'm looking at this table and I see that I've got two numbers, the 14 whole number and then the 28.085. We know that whole number is always our protons. So I can pop that in right up here for number of protons. And now, because the mass number is not found on the periodic table, I need to do a little calculation. Protons plus neutrons. So I'm looking at 14 plus 11 to let me know my mass of this particular isotope of silicon will be 25. Back to electrons. Again, I know that's always going to be the same, so I can fill that in as 14. Okay, uranium, this is a large one. Uranium-235. I have a couple options here. I could go right to the periodic table and look up my protons, but I also have some information just right here on my list. Again, we know protons are always going to be the same as electrons, and again, mass number is a calculation of both of those. So if I know my total minus my protons, that should calculate out to be the same, number 92. Okay, so a couple more here. Let's do these real quick together. Again, mass number is looking at protons plus neutrons. I know my number of protons, so I can do a calculation to get my number of neutrons here. And electrons, again, always the same. Positive equals the negatives to cancel out. Our final one, we do not have an element name or symbol, but I do know the number of protons. So I do need to search and find my element that has a mass, or excuse me, protons of 25. Here it is here, manganese. So I've got 25 protons. Remember, this is my atomic mass. So this is the average. I cannot use this to determine my mass number. I need to stick with that protons and neutrons. So this is our manganese. with a symbol of capital MN. Protons are 25. So to figure out my neutrons, I've got the total minus protons. Calculates out to 31. And finally, as always, protons equal electrons. So the big thing to remember here is that mass number is not on the periodic table. That's specific to that isotope, and it's always that simple addition of protons plus neutrons.